Okay, welcome back. I've gone through and created the rest of our orientation nodes and oriented the rest of the skeleton here, as we can see here. Most of the way I've oriented things is with the z-axis pointing down the chain, and our main rotation kind of being either the x-axis for our arms and limbs and the y-axis for our fingers here. Perfect. In this video we're going to talk about creating twist joints that we touched on the topic of conceptually when we were creating the arm bone and the arm chain of things. To start, I'm going to just create twist bones in the arm, and if you would like to play around with creating your own twist joints in a different fashion, you could do so on the leg or even on the arm if you find a way that you want to do it preferred over the way I'm about to show. Essentially, twist bones are just points in between our end point, which is usually our wrist, and our elbow. We can also have twist joints. We can see some rigs have twist joints in their upper arm as well for really high fidelity. It all depends on what your needs are and how detailed you need your capture weighting, your skin weighting. But for us, just a few twist joints in the lower arm will do for us, I think. And I'll show how we can make it for the upper arm at the same time, in case that's desired for your pipelines. First, we're going to put down a delete joints node, and we'll see this process is kind of similar to creating controls, how we did so earlier with our tube. We're going to take the joints we need and we're just going to edit from there. So I'm going to take our shoulder joints, or our arm joints rather, and we'll just edit from here. We don't need to be editing the rest of the skeleton. We just need our arm, and we can either blend back in our skeleton or combine it in a different way with our parent joints node, as we did with the tip for orienting the pelvis. So delete joints, and we're going to get arm. Perfect. Now, twist joints are, like I've been saying, just a bunch of points in between the 2 points here. So we can just use a resample node to split up our primitives here to have multiple points. And the number of points you create is up to you. It like I said, depends on how detailed both you want your capture weights, and it's kind of dependent on how detailed your mesh is. If you have a high fidelity mesh with many subdivisions, nearly photorealistic, or just something very high detail, you'll want more bones to match that high amount of detail. But for this character, we can get away with a modest amount of bones. So I'm just going to play around with this length parameter to see how many bones I can get that I would like. I think 3 on each section is pretty good. I like that. We'll notice when we resample our primitives here and we put this into a rig pose again, we'll see that our elbow has been split up into multiple joints here. And that's just due to the nature of how our resample works. So we'll want to fuse those back together just with a simple fuse SOP. and we can just do it snap distance. That should hopefully do fine for us. And if we put a rig pose after this now, hopefully our elbow is just one elbow now. Now we do get this interesting phenomena happening here where we've grabbed our elbow and yet we're editing a lot of joints here for some reason. Well, it's because our resample node did its best to apply naming to everything it could in as logical a way it could think of. And we can see here we have elbow, 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 and our rig pose grabs by name. So when we edit one joint with the name elbow, we edit all of them with the name elbow. And the same will go for this wrist down here, as you can see there. So we have to go through and rename our joints, but we don't want to rename all of them. And we also might want to do a quick orientation on some of our joints. We can see that they don't quite point down the line exactly as we would hope. So we'll want to go through and do that as well. So let's go through by just trying to take out or group our twist joints. I'm going to do this by trying to do this as best I can so that we can come back and edit the number of twist joints we want to, if we need to. So I'm going to start by just grouping our endpoints, which will at least take our shoulder and our wrist out of the way. And just to, as a further explanation why I placed a second shoulder joint here, we can see it allowed us to have these twist joints in the center of our mass rather than if we were to have connected our shoulder from here to here. It would have created a lot of odd points for a twist joint to be. Anyhow, let's just group by range real quick. And we'll get our end points. So we'll get our wrist and shoulder, which we'll just call end points. We're going to group our points. And we're going to just grab our end and start. So when I came in here to grab my endpoints, I didn't see that our point order was in an order I didn't quite expect it to be, with 0 in the middle and 8 being right next to it for some reason. When I built this earlier on my own, designing the course, things kept in line with this order of things, but it's fine that things went that way. We can simply put down a sort node here before we start grouping things, and we can sort out our points. And we could do so by just the x-axis. And there we go. We can see that as we go out, we have 0 and 8, how we need to have it. And now when we grab our end points, we get the 2 points that we need, the shoulder and the wrist. Perfect. We're going to call this fuse elbow, just so we know why we have the fuse, and sort, reorder, points. And resample arm. Perfect. So our fuse node here has the ability to create a group called snapped points, which are all of our points that happen to be fused together when we use the node. So that'll give us our elbow here. So we can put down a new group node, and we can use our already put in endpoints. We'll make sure we change that to points, and we want to combine with our base group of our snapped points, and then we have our 3 points without entering in any numbers by hand of our shoulder, elbow, and our wrist there. So we can do combine elbow or snapped and combine snapped and ends. So we have our end joints, and now all we have to do is get the inverse of that. We can just actually just grab all of our joints here. If we create a new group and we grab our endpoints now as a base, which should have our endpoints are going to be our base. My bad. And we will just grab all of our other points, call them twist joints, and we can subtract from existing. So now we have our shoulder, elbow, and wrist, and all we need to do is subtract these this group from another group that contains everything. So let's create a few more group nodes real quick here. We will group all, and we'll start our twist joint group here. Twist joints, and we can see that we want it to be points. We're grabbing all of our points. We'll make one more group node, and we will extract the twist joints out. So we can use our endpoints as a base group, and we can make sure we do a subtract from existing, and we want our twist joints as our main group here. And we now have just our twist joints in here, and if we come back up and change how we resample our curve, we should still have all of our twist joints grouped together how we need to, and we can affect them from here out. Now we just need to name all these joints and just this group of joints individually, and we're going to do so with a simple wrangle node real quick. So if we put down a wrangle, we can create a quick string parameter, call it joint name, and we can make that equal to our string of our name of our joint. And we're going to grab our twist joints here and make sure we're using points. And we're going to make sure we spell things correctly. Perfect. String joint name. That should, not give us an error anymore. And we're going to grab the int of our point num. We're just going to create a point num integer. We're going to grab the integer attribute ptnum, and we will just quickly make a new name and apply it to these guys. We actually didn't necessarily need to grab our string joint name, but we're going to now set our string attribute name to be equal to whatever you want it to be. I'm going to make it L-arm twist, and I'm going to add a string version of our point number. So we'll have a L-arm twist 1, 2, 3, 5, 6, and 7. If you want to get fancier with your naming, to make sure it just goes 1, 2, 3, 4, 5, 6, 7, instead of skipping 4, then go for it. I'm just trying to get special names for each of these twist joints. To get a string of an integer, we're going to use the itoa input here, and we're going to grab that iptnum. Perfect. Now that should give us individual names. When we look through here, if we open up a rig pose and we start looking at our individual arms, we now have L-arm twist joints. And once again, if we come back through and change our resample node to have more twist joints, we can, it'll name everything for us, and we don't have to worry about renaming anything by hand. Now all we need to do is orient our twist joints real quick. And I'm going to do so just by grabbing those twist joints again. Perfect. And we're going to orient down the z-axis. And that should be all we really need to do, just to make sure that Z snaps to look down the chain again. If you want to put in a up vector, just to make sure things are in line with how you need them, go for it, but it looks pretty good to me right now. So that's how I've set up twist joints. We can now re-grab in. So if we had that split here, we can duplicate that delete joint, and instead of deleting non-selected, we can just delete selected. And if we want to, we could put in a merge. As such, we now have all our joints back in place, and we could put down a parent node, a parent joints node, and simply reparent everything the way we need to. With our wrist to our fingers, the primitive count is getting to me a little bit, so I'm going to turn those things off. And our shoulder to shoulder. And there we go, our hierarchy is restored. And we now have twist joints in place. Alright, so we have our twist joints in place. Our skeleton is just about done. All we need to do is mirror to our right side and get our right side going. So we can do so. The basic node we're going to do and need is the skeleton mirror node. As we put it down, we notice that we get this blue plane in the way that is naturally on the YZ plane, and we notice we mirror everything, including our spine. You can see that we have 2 spines on each of those points, and our axes are nice and mirrored, which is exactly what we want. However, we don't want to mirror the middle section. We don't want to mirror the spine and the head and the cog and the pelvis. We just want to mirror our arms and our legs. There's a couple ways we could do that. One way is manually. If we want to just enter our group, we can just select the group by hand like such, and now we are just mirroring our points that we selected there. We can also use this find and replace token to find our L underscore and replace it with an R underscore, which is where our naming convention comes important here. We can see now that we have these R clavicles and all of that. Nice naming is in place due to our previous work on the left side. So manually is fine. If ever we come back up the chain and we, for instance, edit our twist joints that we don't like, or if we add a joint for some reason, if while we're skinning we realize, oh, it'd be nice to have some sort of rotation on the shoulder here, then we'd need to come back through and reselect our skeleton. So I'm going to set up a quick workaround for that so we can come back up the skeleton and edit things. I'm going to put down a group. We're not going to have a base, but we are going to have a bounding box, and we're going to move it to be flush with our ground plane. So we're going to copy this parameter, paste it as a relative reference here, and we're going to divide by 2 so we get it flush with the ground plane. Perfect. And we're going to do the same over here. We're going to copy this parameter and we're going to paste it here. We're going to divide that by 2, and now we're only on, we have this box only on the left side, and we can just edit how tall it is, and we are now selecting all of just the left side. We get a little bit of the center here, so maybe we can add 0.1 to this, and now we won't get any of the or 0.01, my bad, there we go. Now we won't get any of the center. We can change this to points since we want to make sure we're mirroring points with our skeleton, and then we can come in and we can call this L side, L box maybe, and we can start to either use that group to mirror things. Sometimes we might have trouble using that group, but if we just enter it manually, it should pop up and work fine. Perfect. Now whenever we come back up and edit anything above the chain, it'll naturally mirror over so long as we have our tokens in place, and we don't have to worry about manually entering any information anymore. We can notice that our mirrored attributes, we can add attributes to them, like a mirror attribute naturally gets added, and we can also add other kinds of attributes or transfer over attributes if we want to. And naturally all of our attributes are transferred over. We can also change if you're using the x-axis as your forward axis and are mirroring across, you can change your plane down here. Now we've completed our skeleton, everything is in place, and we'll talk about skin weighting next.